Which of the following explains why the melting point of iodine is I2, is higher than that of iodine chloride, ICl? A. London dispersion forces are stronger among iodine molecules, which are larger and more polarizable. B. ICl molecules are capable of dipole-dipole interactions, whereas I2 molecules are not. C. Both, or D. Neither. Think about it. Where would you find iodine and chlorine in your periodic table? Fluorine, chlorine, bromine, iodine. So what's the trend in size? Going down. Size increases. So which one's larger, I2 or ICl? This is larger, right? And what is this thing? The melting point of I2 is higher than that of iodine chloride. Now, which one's polar and which one's non-polar? Iodine is polar or non-polar? Non-polar. ICl is polar. So, what would explain why I2 has a higher melting point than iodine chloride? Is it A, B, C, or D? Ooh. All right. Let's look at the first choice first. Let's look at choice A. I2 molecules are larger. Is that correct? That's correct. They're more polarizable? That's correct, right? So they have stronger London dispersion forces? Yes, that's correct. Does that explain why the melting point is higher? Stronger forces of attraction? Higher melting point. Higher melting point and higher boiling point, right? So that's good. A is okay. How about choice B? ICl molecules capable of dipole-dipole? Yes. I2 molecules not capable of dipole-dipole. Non-polar, non-polar. So they're not capable of dipole-dipole. So that's okay too, right? So the statement is true. Statement B is true, but does it explain why the melting point of iodine is higher? So if ICl is polar and I2 is non-polar, if you're just basing your explanation on polarity, prediction on polarity, what would you predict? The polar molecule you'd predict would have stronger forces of attraction, right? And if they have stronger force of attraction, you'd expect them to have a higher melting point. So the polarity cannot explain the melting point. What this is telling you, so this is false. Although this statement is true, it's not consistent with the experimental observation that the melting point of I2 is higher than that of iodine chloride. So this is true, but does not explain the fact. Okay? What that is telling you then is that in this particular case, the primary determinant as to how to explain the melting, as far as the melting point is concerned, as far as attractive forces is concerned, is London dispersion forces. Okay, so and if you look up your melting points of iodine and iodine chloride, you'll find the melting point of iodine is in fact larger.